Hello, everyone. Welcome to this lightning talk, Shaping the Future of Cloud-Native Infrastructure in the Age of AI, 5G, and Edge. My name is Ying Xiong. I'm with Futurewei Technologies. Today, in this talk, I'm really excited to introduce you a new open source project that is designed for next generation applications. So let's go ahead and get started. First, let's look at some of the challenges that we are facing today. As the cloud adoption grows exponentially, the infrastructure platform needs to manage larger and a larger scale of compute and network resources across geographic areas. The customer always asks for faster and faster provisioning of the resources or the applications. Additionally, there is an increasing need for cloud operators to unify the management of diverse types of resources, such as bare metals, VMs, containers, and serverless functions, to just simply reduce the management cost and simplify our operations. With the emergence of the new type of workloads, such as AI, 5G, and IoT apps, we see a trend that traditional cloud computing and edge computing are being converged into one distributed cloud. This trend requires that the current infrastructure technologies need to be redesigned or optimized to support applications running at resource-constrained edge nodes that are closer to the customer and the customer data. As a result, for those new type of workloads, we need the cloud infrastructure to be able to intelligently place where the application should run in order to improve customer experience with low latency and high throughput. Last but not least, the trend in the area of cloud native continues. Due to its extremely scalable and extensible design, we believe the modern cloud infrastructure should incorporate this cloud native design pattern into the platform to meet the challenges faced by new generation of applications. So now I'm pleased to announce and introduce you the new open source project called Centaurus. The goal of Project Centaurus is to provide a new infrastructure platform in a more cloud-native way for any company to build scalable and unified infrastructure for the public or private cloud. Centaurus platform is designed from its beginning with hyperscale, edge computing, and fast compute network provisioning in mind. Centaurus projects actually consist of two sub-projects. We named them Arktos and Mizar. More detail on Arktos and Mizar will be discussed in the following slides. This is our architecture of Project Centaurus. I won't be able to deep dive into this architecture in detail, but I would like to mention a few highlights. First, regional scalability. One of the visions for the Project Centaurus is able to support a cluster of 300,000 computing nodes and be able to provision and manage more than 10 million network endpoints within a region. So every component in this architecture can be partitioned to handle a large number of requests. Second, this architecture natively supports edge computing. It's built in to schedule, run, and manage applications at edge size. Lastly, this architecture also offers the same API experience for both VM and the containers, as well as for other types of workloads. It provides application-centric API, is a platform for both resource and application orchestrations. Centaurus Arktos components is derived from well-known Kubernetes architecture. However, we made some major redesigns and extensions to the core of Kubernetes. Here is a list of the changes that were made. Partitioning and scalability. In Arktos, API server, etcd store, controllers, schedulers, all can be partitioned for large-scale deployment. Multi-tenancy. Arktos introduced the true and hard multi-tenancy into the Kubernetes and make the platform a real multi-tenant platform. Unify the runtime. Arktos unify VM and the container runtime into one, so that the platform manages VM in the same way as it manages containers. Arktos introduced new network object types and the corresponding operators. This is a part of a multi-tenancy model, so that containers or VMs are created within subnet or VPC, and they are naturally isolated. Built-in edge computing. Arktos out of the box can manage computing nodes at the edge size and orchestrate applications running at a resource-constrained edge. Similarly, Centaurus Mizar component is a network component that provisions and manages the virtual network and processes network traffic. Mizar itself has two components, data plan and the management plan. The data plan is built on top of high-performance XDP/eBPF programs. XDP programs running within the OS kernel to perform routing, switching, and a load balance of network traffic. Mizar using natural partitioning of a cloud network such as VPC and subnet to scale network endpoint provisioning for tenant VMs or containers, as well as for fast networking forwardings. Mizar management plan runs within a Kubernetes and using Kubernetes CRD and operator framework to manage virtual networks and network package routing policies. That's all for me for this short talk. Thank you very much for your listening. Please visit our virtual booth for more detail about projects and Centaurus. Thank you very much. Bye.
非常感谢刚才熊总的一个分享啊，然后熊总现在也在我们的线上，我刚才看到在我们的直播间里面有一些问题啊，下面我们邀请熊总进行一个我们的在线的 Q&A。
好，谢谢。您能听得见吗？
可以听的。
行，我来回答第一个问题啊。第一个问题是说，可以分享一下未来运营开源项目 Arktos 的规划吗？Arktos 这个项目已经是开源了，所以你可以在 GitHub 上面可以看得到。这个项目本身就已经运行一段时间了每周都有每天都有 Slack channel 你在 Slack channel 里头可以去提问题或者去provide ideas。同时每周有一次的开源会是在周二的北京时间周三的早上。
好的，我觉得一会儿熊总可以把您的这个在 GitHub 上的一个地址来分享一下
这个开源项目的地址是已经在 slides 上面大家可以看到。
好的，好的，好的。
应该是很简单github.com/futurewei-cloud/Arktos 或者是/Mizar 是两个 subject 两个不同的开源项目，一个是网络的，一个是计算的。
好的。
第二个问题是any plan to host the two open source projects, Arktos and Mizar, in a vendor neutral organization? 我们正在跟Linux Foundation 在交流准备把这个两个项目一起推到 Linux Foundation 下面具体的哪个 Foundation 组织还在讨论，还没有完全定下来。
OK， 那就请大家持续关注我们的一个接下来的一个合作的一个动向希望那个我们熊总和我们的 Futurewei 以后能够开源出来更多的好的项目
多谢，谢谢。
好好的，我看到好像没有其他问题了。好，那我们就非常感谢熊总您的分享你也辛苦了，好，谢谢。